Hi everyone, welcome to day 5 of Advent of Code 2023. Today's a bit more challenging, but I'm going to go through the problems and my solutions as usual, and we're going to start with the time lapse. Alright, not gonna lie, that was pretty hard, but let's go through the puzzles. Today we are given a set of seeds, and through a series of mappings, we need to map each of the seeds, which are each an integer, to a location. Essentially, what is going on here is we're just doing some integer manipulation from ranges to other ranges. So we're given a set of integers, which are the original seeds, and for each of those seeds, we need to convert to a soil integer. So the soil integer is going to be just another number on the number line, and we're told how to map seeds to soil using a series of mappings. How these mappings are structured is that we have a destination index, a start index, and the length of that range. So if we have 50, 98, and 2, this line in the mapping tells us that any seed that starts at index 98 or 99 will be mapped to range 50 and 51 for the soil. So if, let me pull up the OneNote, we have a 90, or rather it was, what was it? 50, 98, and 2. Basically, we have our seed index, which lies on a number line, and we have a soil index, which also lands on a number line. This is the source index, so 98, starting from 98 and having a length of 2, all of the seeds in this range are going to map to 50 and 51 in the soil range. So 98 is going to get mapped to 50 and 99 is going to map to 51. If this integer were instead, say, 10, then we'd have a range of length 10. So instead of just 98 and 99, we'd go all the way from 98 to 107. So there's 10 numbers here. This would map to 50 through 59 in the soil number line. So all of those 10 numbers would map to these 10 numbers. And that's how the mappings work. So after we convert from seed to soil, we're also going to have to convert from soil to fertilizer, fertilizer to water, etc. All these conversions. So basically, we're going to have like 7 different number lines: 1, 2, 3, 4, 5, 6, 7, maybe 8, because there's one more than the number of mappings. So 8 number lines. We're going to have to convert from seed, going down up to down to location, I guess. And once we have the locations of all of the seeds, then we need to return the minimum location of any of the seeds. So relatively speaking, part 1 is much easier than part 2, in my opinion. Basically, all we have to do is go through all of the ranges. We need to figure out a way to basically map from number lines to other number lines based on this text-encoded mapping we're given. We're going to split it up based on seeds. So I'm going to write this function called findLock, which takes an integer, which is the seed index, and it will convert it to a location index by going through all the mappings. To parse this, basically, we just have to get all the numbers, and that's what this is doing. There's nothing fancy here. We just go through all the sections, starting at index I equals 2, which is the second line. You just go down, read all lines as long as they're not empty, and all of those will have 3 integers each. Just record them inside this maps array, and once you hit an empty line, you start the next one, and that's basically as simple as it gets. Because the mapping bit is actually quite non-trivial. I'm realizing I don't actually need this line right here. I think it'll run fine without that. Yeah, we don't actually need the names of the categories. They're going to be the same: seed to soil, soil to fertilizer, fertilizer to water, etc., etc. Okay, so to take a seed index and convert it to a location index, we go through all of these mappings for every single seed, or rather for every single range in this mapping. So we know that in the number line, here's a generalized picture. Say we're going from seed to soil, but this could be any 2 number lines, really. You have a bunch of ranges which get mapped to different sections of the other number line. So say this range maps to here, that range maps to here, this range maps to here. Oh, and by the way, if there's no ranges that match, then we simply just transfer it directly. So any seeds lying in this range are just going to get plopped straight down into the same index in the soil range. And there can be overlapping ranges, of course, because I guess that's just how the problem is. I did confirm for my input that all of the input ranges will be disjoint, and that's really important because if you have 2 ranges that are not disjoint, then say, these are 2 input ranges, then and like it's here, and any of the seeds in this sort of overlapping area will get carried to two different locations, which is kind of invalid. So we need to have a one-to-one mapping. So all of the ranges, when you have your input, must be distinct. So we're going to go through all of these ranges, identify which one the seed is a part of, because again, there can only be one range that this seed can be a part of, and just calculate where it goes. To calculate where it goes, we take the destination start, subtract the source start, and that's going to be the difference here. So let's say this range over here maps to this range. This is the destination start, and this is the source starts. Any number in here is going to get mapped to x plus destination minus source, because everything in this range just gets shifted over by that amount. And that's exactly what we're doing here. By the way, if you don't catch all the code right away, that's okay. I'm going to include my code in the description below. There's going to be a GitHub repository which contains all my code across all the days. And you just sort of let that run through all the 8 categories, and at the end you're going to end up all of the seeds with their corresponding location. Once you have that, you take the lowest of all the locations, and that's going to be our answer. So I think that should be it for part 1. For part 2, we are told that each of these numbers in the seeds line does not actually correspond to an individual seed, but rather a range of seeds. So over here, if we have n integers in this input, there's going to be n over 2 seed ranges. So instead of 79 and 14 being individual seed indices, we need to consider them as a range of seeds starting at 79 and going 14 out. So all of the integers from 79 to 92, which is 14 away from 79, are going to be part of our input, and all those 14 seeds need to be run through the entire algorithm and their locations computed. Similarly, at the end, we just need the lowest location number of all of the seeds. So this is quite non-trivial because our input is kind of large. You can see this one has like 37 million seeds. This one has, I want to say 4 billion, which is a lot, and so on and so forth. So I thought a naive solution would not work. It might though, so I'd love to hear in the comments if you tried that out, how long it took and your approach. But I tried to do something a little bit more contrived and generalizable. So essentially what we're going to do here is instead of computing where individual seeds go, we're going to compute where ranges go. And this is slightly more complex, but it's faster, I believe. So what we're going to do first is inside each of the mappings, we know, for example, let's take the seed to soil example as usual. And once we have this, we can just apply it to all of the other ones. It's the same idea. So if we have seeds and soil, let's say we want to compute where this range of seeds will go. We're going to generate a list of intervals as our answer. So our answer is actually going to comprise of a set of distinct intervals, and that's what my code here is doing. So we have this function remap, which takes a low index and a high index in some number line, and m, which is the mapping, corresponds to one of these 7 things, and it's going to output a list of intervals in the resulting number line. So that's going to be our result. It's going to be a list of these intervals. And how are we going to compute that? Well, let's take a look at what could possibly happen. So inside the mapping, we're going to have a list of intervals which cover the source number line, and they're each going to get mapped to some ending range. The nice thing is that each of the starting intervals is only going to map to one contiguous output range, so it doesn't explode that much. So we're going to go through each of the entries in a mapping, or rather m, our variable over here, which describes the current mapping, and we're just going to chug along sequentially. So we do have to sort by starting index, and that's going to make it really nice to process just sequentially. And we're just going to sort of march along every time we see one of these, if it intersects with the input interval low-high. So we're going to check that by verifying that the ending index of the range is to the right. Sorry, the ending index of the range is not to the left of the starting index of our input interval, and the starting index of the range is not greater than the higher index of our interval. So basically checking that it overlaps. As long as it overlaps, then we can compute where it overlaps. It's going to be the maximum of the source interval mapping index and our low I guess, starting point for our input interval and the minimum of our ending index for the range and our high index for the input interval. So basically, that's just computing the intersection of the mapping range with our input interval. Once we have that, we can also assign an index, rather a difference d, which tells us how far we need to shift the entire interval. That's going to be this distance over here, and we're just going to add that to our result list. We're going to do that for all of the mapping ranges inside the current mapping, and once we have that, we're going to have a list of basically like little segments of our input range, and we know where each of them will go. So they're all going to be clipped. If there's any ranges that intersect but lie completely outside or partially outside, then we will know. And yeah, that's basically what we do. Once we have this, we know there's some edge cases. Of course, when you have like the starting range doesn't intersect with the beginning, but we cover that in these 2 lines over here. So nothing too these 4 lines over here. So nothing too complicated. And we also need to take care of the intervals that don't map to any ranges. So all of the stuff in between here is just going to get directly mapped onto the soil timeline. Sorry, this is a bit of a messy picture, but that's what these 2 lines cover. And at the end, we're going to have all of the ending intervals for our single starting interval. It's going to be a list. In Python, I'm using the yield syntax to create a generator. So I thought it was just easier than making an answer. This is just slightly more direct. If you don't know, a generator is basically a way of creating an iterable object using a function. So that's very nice. Yeah, so one interval is going to get mapped to multiple intervals, and we just kind of do this for all of the mappings. We start with seeds. We're going to take a single interval, described by 2 numbers in the input, and chug it through all of the mappings, just by basically doing them one by one. Whenever we generate a new interval, we will compute its like child intervals, basically. It's nothing too complicated. There aren't actually that many generated, and at the very end, we just look at what is the lowest location index. So yeah, that's a bit of a high-level overview, but that should be it for part 2. Basic idea is just I calculated, instead of where individual numbers go, where intervals will go, and splitting the intervals as necessary in case they're disjoint. So that's it for Advent of Code 2023, day 5. I would say it's a lot more involved than the previous days, though I will say this year has been harder. It started off on a quite challenging note. So I'll be back again tomorrow for day 6 with explanations and solutions as usual. If you have any questions or comments, feel free to leave them down in the comments below, and check out my code, which is linked to in the description. I guess that's it. So I'll see you tomorrow, and thanks for watching.